Greetings and welcome to another short and sweet talk. This should be the third one on vectors because promised you a little short toolkit on vectors. Now on the page here you see a piece of graph paper. A few years ago I went to see Joan Jett and the Blackhearts in a place called Cedar City, Utah, which is an outdoor amphitheater. And they have little square blocks that you sit on, and each of the squares here will be about 10 meters in size. And the stage was this direction, the entrance is here, and I went there with a nice young lady named Lulu O'Shanashay, who liked to run around and all this other stuff. And it was kind of makes an interesting vectors problem, because when we got there at the entrance, first thing she did, because of the little blocks of cement, is she ran immediately 20 meters. So let's see if I can come up with a color we haven't used here. So she ran 20 meters this direction. So after her first move, she's gone to here. Her second move was to run 50 meters, 1, 2, 3, 4, 5, this way. And she was then here. After that, she ran 30 meters this way. So she saw a friend this way, stopped to get herself a drink. Then she decided she wanted a t-shirt. So she then ran this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to the t-shirt stand. After she was here for the t-shirts, this was over here for the drink. This was the restroom, in case you're curious. And then she saw a friend up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. She ran to see her friend up here. Helps if I had a ruler, I guess, but she... Hello again. I decided to fast forward because this is starting to get a little bit long and I don't want this recording to take all month. When it was all said and done, she ran in 20, she ran over 50, she ran up 30, she ran to the left by 100, ran up 200 meters, 80 meters to the right, down 100, back over 150, up 270, and to the right 130. Now the question is, how far did Lulu go as far as she ran, and how far did she actually get from the entrance? Well, if we cheat a little bit and pull out some math, I get, this is her directions in the left and right things. If you notice here, I have 20 there, that's that 20. 50, that's there. If I go through the table, you can see very quickly that she ran a total of 1,130 meters. She got 420.12 from there. The way I got this was I took the sum of the x plus the sum of the y, and I Pythagorized it. When I'm done, if you put in 10 squared plus 420 squared, take the square root, you get 420. If you take the angle and take the arctangent of 420 divided by 10, you get the angle of 88.64 degrees. And if you look at this, you can see she almost went up at a straight angle. I got in hold of some pretty good seats at this concert. Now the reality was I didn't draw this quite right because the stage was actually right there. We were in the front row. But hopefully that helps clear up what you do with the component method of doing this, where you can chase where the person runs around, or you could try to do the heel-to-toe drawing and then see what you could do as far as, hey, can I draw this and go to that, measure this on a scale, measure the angle and all this other stuff. You can see, even trying to draw carefully, one little mistake and you mess it all up. That's what's really nice about the component method. We'll be discussing this more in class, but hopefully that gave you a very short, quick, dirty, nasty lesson on how to do some quick trigonometry necessary to run vectors here in the physics class. And we'll answer questions when I see you.